Hello, today we're going to discuss about application and the principle of derivative. In this video, we're going to discuss more about what kind of question or problem-solving question that require us to do a derivative. So there are actually three instances that you need to understand on where should we do derivative. So the first one being finding an instantaneous rate of change. Second one is to do optimization. And the third one is about the kinematics. So in this video, we're going to focus only on the instantaneous rate of change, and the next two will be added on the later video. So first of all, what do we need to do if we want to find out the instantaneous rate of change? So the first thing we need to do is that we need to find out the equation of the curve, or the equation of the function. Just take a look at the question there and find out what is the question, and also you need to understand what is the variable represent on the equation. After you get the curve, you can start doing the gradient of tangent. So what is this means? It means that you derivate the equation because the main function of the derivative is to find out what is the gradient of the tangent. So after you get the gradient of the tangent, then you can plug in the value of x or the value of the variable into the first derivative equation that you just got, and the value you get in there will be the gradient of tangent. So why do we want to find out the gradient to find the instantaneous rate of change? This will explain with the question after this. So let's say we have an example question. The profit projection of product D can be explained through the equation of Px is equals to minus 0.5x squared plus 5x plus 10. So these are the equation that you need to find first when you want to do rate of instantaneous rate of change question. So the Px, let's record that one. So we have the equation of Px is equals to minus 0.5 x squared and then plus 5x plus 10. That's the equation that we want. For the next 5 years, where Px is the total profit in millions dollar, and X is the number of products shipped in 100,000 units. Now, the first question, as of the current year report, the company managed to ship $200,000 until unit to the market. One of the board members is happy about the profit made and suggests that the company should ship as many products as possible. Would you, as the manager, agree with the statement? And the second question, decide at how many shipped product would the company operate at maximum profit? Okay, so our goal here is to answer these two questions. Yeah, so we're going to do it two ways. We're going to do it by looking at the graph. That's the first way. And the second way is that we're going to forego the graph and we're gonna try to do derivative to solve these two equations. So let's take a look at the solution with the graph first. So these are the graph of the equation of the profit that we just write before, that one. So how do we actually answer the two questions? So remember that the first question is asking us about the statement of the board member when it says that, okay, because we make a lot of profit by shipping 200,000 unit. So what happened if we ship more, Basically, if we ship as much as we can, I think it will produce a lot of profit. Well, it's not like that because the equation of the profit that we have here is actually a parabolic equation with a maximum value. So in that case, after a certain amount of product shipped outside, the profit will not be increasing anymore. But instead of increasing, it will start going to decrease. So as you can see on the graph in here, we know that the profit will be the highest at what? When we ship around 500,000 unit, like here. So 5. And remember, the 5 in here represent the um represent the number of the units shipped in here. Sorry about that one. There's like a bit of a technical issues with the pad here. Okay, so the amount of profit that we have will be at maximum when we can ship 500,000 units. And after that, so when we can see that when we ship the product above $500,000, yeah. So as we can see here, the profit is decreasing. And then if we ship the product from zero from from here all the way to here. So pretty much like when it is less than 500,000. So we are actually making profit in that sense. So that's how we answer the question when we take a look at the graph. So the first question will be the statement that is said by the board member is not entirely correct. It's only correct until we hit 500,000 shipment. Because after that, the profit will start to be declining. And the second one, the second question that is asked in here, uh, so what is the maximum profit possible? Well, the maximum profit that we can get from this shipment of product is when we ship around 500,000. So it's pretty easy to see if we have the graph. Now, what about if we want to solve the equation without the graph? So what can we do here? Now, let's try to move into the next slide first. Okay. Now we need to solve the equation without the graph. So in many questions, it won't be this easy because the equation of the curve that will be given can be vary. It can involve log, it can involve Euler, or it can involve square root and stuff like that. And it is not advised for you to actually draw a two-scale graph. So instead, you need to do the question without using the graph at all. So the two questions remain the same. So the first question is that we have to agree or disagree with the board member statement about we can ship as much as we want if we want to make more profit. And then the question two, we need to find out at which point, yeah, at which point the profit is maximum. Okay, so now we have these two questions and we have this equation. So the idea is that when we take a look at the graph before, right, we can see where the maximum at, yeah? And then if we try to draw a tangent line on that maximum point, so what is the gradient that we will have? Because at the maximum, the tangent line is a straight horizontal line. So that means that the gradient must be equal to zero. So we can say that at maximum profit, yeah. So in here, the gradient of tangent of tangent will be equals to zero. What does that mean? So it means that the instantaneous rate of change of the at the maximum profit is equals to zero, right? Because the gradient is a flat line, a flat horizontal line. So in that case, what can we do? We can just try to derive the first equation of the curve here. So P prime x will be equals to minus 1x plus 5. And that will be, and we want to make sure that the gradient is equal to 0. So everything in here must be equal to 0. So in that case, we get that x equals to 5. See? So we get the same answer with the graph before. So we know that the maximum profit will be determined, will happen if we ship 500,000 goods or 500,000 product outside. So so in that case, for question number one, we can actually get a more complete question that way. So we do agree to some extent, right? We can actually ship more until $500,000, right? Because and after that, we don't want to increase our shipment. We just want it to stay that way because that's where the maximum profit at. Because if we add more, then the profit will not be increasing, but instead it will start declining. So that's the idea for that one. And for question one, we agree, yeah, to some extent, yeah, which is we don't want to ship more than $500,000, 500,000 units outside. Okay, so that will be the answer for number question one. So what about in question two here? At which point the profit is maximum? Well, we already get the answer, right? So when we ship $500,000, right, then we're gonna end up with the maximum profit. So To get a better understanding about the shape of the graph, I mean, we can try to imagine what kind of shape, what graph shape that we will have in here. Yeah. So imagine if I were to make like a sine diagram like this. Yeah. So I know that the maximum will happen when the x is equals to 5. So this one right here will represent the gradient. Yeah. And when we put x equals to 5, the gradient is 0, right? So what does that mean? So it means that when the x is less than 5, the gradient can be positive or negative. So how do we get that? So the thing that we can do here, just try to plug in any x value less than 5 into the derivative equation. So for example, if I put like p prime 1 in here, then I'm going to end up with 1 minus 1 times 1 and then plus 5. So I will get 4. So in that case, we have a positive gradient alongside the x less than 5. What does that mean? So it means that the profit will keep increasing. Yeah, will still be increasing if we increase the product until $500,000. Yeah. And after that, when we put x bigger than 5, so let's just put x, let's say, equals to 7 on the equation. So we have p prime 7. That'll be equals to minus 1 times 7 and then plus 5. So we're going to end up with minus 2. So as you can see here, the gradient is negative. What does that mean? So it means that when the gradient is negative, so the more product we ship after that, the profit will not be increasing anymore, but instead the profit will be decreasing. And that's how we apply a derivative into instantaneous rate of change or into a gradient sense. Yeah. Okay. Now, what about if we apply restriction into the equation? So what can we do? If we apply restriction like what we have in here, the company can only ship at most 400,000 products. So in that case, we take a look at the sign diagram again on the gradient. Yeah. So what is the instantaneous rate of change when the product is at 400,000? So as we can see on the sign diagram here, for any x value less than 5, the what is it? The gradient or the instantaneous rate of change will still be positive. What does that mean? So it means that as long as this company can ship less than $500,000, so we can put as big, we can ship as many as we can that the company is capable of to get a maximum profit. So in that case, if we want to find the maximum profit in here, we just try to put x equals to 4 in the original question. So we get P4 will be equals to minus 0.5 and then 4 square plus 5 times 4 and then plus 10. So in here, we're going to end up with, what's that? So minus 8 and then plus 20 and then plus 10. So we're going to end up with 22. Okay, so 22 million. So that will be the profit that we can get if we ship 400,000 400,000 product outside. And that's how we apply the derivative in an instantaneous rate of change. Okay, so hopefully it can be understood.